Okay, we should be good to go. Audio's working. Looks like the screen's streaming. So today is gonna be a short stream. I gotta go pick some stuff up in a little bit. I mean, like 5 or 6 hours instead of like 8 to 12. The front end is basically done. There's various things that could be done, but I think I was starting to think about this last night. There's a lot of other stuff to do. I got to do the back end. I got to do CI/CD. Like, there's no testing on this. I need some integration, some browser tests, like Playwright tests or something. I have no unit tests either, but I figured I'd implement those as I start to actually hook it up to APIs. But then the thing is like, do you even have APIs with this sort of end-to-end encrypted service? So I was looking at that a little bit last night. Basically, if you have an end-to-end encrypted service, if anyone doesn't know what end-to-end encrypted means, it's end-to-end encryption, e2ee, end-to-end encryption. This is what Signal uses. Supposedly iCloud and other stuff are end-to-end encrypted. You don't know for sure, but the idea is that basically when you upload something to the service just sees the encrypted blobs. It has no access to the underlying data. It doesn't know what you uploaded. It can maybe see like the size of what you uploaded, and when you uploaded it and stuff like that. So there's still a lot of information they have, but they can't actually like see whatever image you uploaded. This is different from, I don't know, most of the web. Basically, like if you upload an image to them, they see the image. There's no, and the reason is because they want to share that image with other people. So if you want it to be a service where basically only people who were allowed to see the image can see the image, not the service itself, not anyone that hacks the service, not any government that has access to the service's servers, you basically have to do end-to-end encryption. But end-to-end encryption is a kind of broad word. I'll get a little bit more into detail on that. The main premise is basically that you encrypt the data goes up to the server sends it to whoever needs the data. The issue with that is that the way most services work is that when you use them, you like create a post. The server sees the post object. It sees what the message is that you created, and then it stores that in a database. So the database basically has every single thing that's been done. It has like every post everyone's ever said is in the backend database for whatever service you're using, Facebook or something like this, Google, whatever it is. And that's useful because now that the server has the unencrypted data in their database, they can do things like search, or you can request the last 5 tags or 5 posts that you've done. And the server knows what the last 5 posts are because it knows that you've written these 5 posts. And it can show that to other people. And then because it knows the content of that, it can use that to advertise to you. And it can also use that to show it to other people who might be doing other relevant things to you. When the data is encrypted, they have no idea what you're doing. And so they don't know, like, if you're doing this, like they have no idea what the content of the things you're doing are. And so the trouble with that, though, is you can't store the data in a database because you don't even know, like when someone sends you data, they need to send to someone else, right? Like you're sending a message to someone on Signal. They don't know what that message is. They don't know if it's a photo or a video. They can see the size, so they might have some hint as to whether it's a photo or a video or something. But basically, there's no way to store it in a database because it's just data. It's just like you don't have any structure to the data to store it in a database to do anything useful with it. So there's variations on that, though. So you can have part of the data be encrypted or all of the data be encrypted. If all the data is encrypted and basically all you know is who to send the data to, you maybe save a database of like the device ID for each associated user ID, so that you can send the data to that device and give them a notification, but you don't know anything more than that. So because of that, that means like to do all this sort of functionality where you have posts and you have events and you have photos, you need to do this all client side, basically. The client is the only one who knows what any of the data is. Like anyone who's in the group who has access to the key to unencrypt the data, they have to download the data unencrypt it, and then they can store it in sort of a local database. And then now you can do queries against that local database. So this obviously has scalability issues if you have tons of data and you're in like 200 groups, and each group has tons of videos and photos and stuff. Now, now you have issues with like how much can you even store on the client before the client runs out of storage space and stuff like that. So yeah, regardless of whatever you do though with end-to-end encryption, you pretty much have to have some sort of concept of a local database. You could imagine though, for example, like when you upload a chunk to the server, like data, you're like, hey, I want to upload this video or whatever. You could tell the server what group ID it's supposed to go to. So the server could have a concept of like, hey, there's groups, and this is the group ID for the group. And when you upload a chunk, you're specifying which group it's going into. Then you can go further from that, which is to say, like, do I know who the users are? So do I know who belongs to each group, so that when someone uploads a chunk, I can just fan out the notifications to everyone who's in that group. So there's sort of a spectrum between everything's fully end-to-end encrypted and the server has no idea that like this data is even in this particular group. That's how Signal works. Signal doesn't know when you create a group that there is a group. They, like, when you send a message, they just see it as you're sending a message to someone else. So when there's 5 people in the group or whatever, you send 5 messages to the other 5 people in the groups, like individual messages, and the client reconstructs it as a group once you open the message. So Signal doesn't even know that you've created a group. They just know that you're talking to 5 different people. So anyway, the point is that the more you know about the data, the more you can kind of build an efficient service, and have more features for the users. And the less you know about the data, the more protected the user's privacy is. There's various different challenges, like even if you encrypt everything, like in the case of Signal, right? You send a message out to 5 other people. Those messages all go out at the same time, basically, because you don't want to have a delay, right? Like you send a message to the group, you want it to get to them within a second. You don't want to like wait a minute for it to get to the other person. And so if you were to look at the server logs, you would see so-and-so sent a message to 5 other people in this 1 minute, and they're doing that consistently. You would be able to tell that they were in a group. So that type of timing, I don't know what the word would be, where you look at the timings of when things are happening and the sizes of objects and stuff, that type of thing gives you a lot of information. So governments could still use that against you, but that type of thing is like a lot harder to deal with legally. Like you don't know who's in the group. Like Signal doesn't know. So like if you subpoena, like, you know, give me the other members of this group, Signal can say like, I don't know who the other members of the group are. Like they could figure it out if you force them to, or like the government could if they were able to like look at Signal's server logs. They could track this and it would be possible to find out who was potentially in the group, but it's not like a thing you can do regularly. Like it's a hard thing to do. So anyway, but if you have a list of the group members, that's the very easy thing to subpoena. Like if you're basically like, hey, I'm going to create a group and I'm going to know who the users are in that group. Now I know who the members are. If one of those people does something illegal and you get a subpoena and the subpoena is like, hey, you got to tell us who the other members of that group are. What is this? Yeah. And they tell you, actually, well, I'll do that in a minute. And they tell you, they tell you have to tell them who the other members of the group are. You have that information. There's different things you can do to make it harder for you to have that information. But the point is like, there's variations, right? You cannot know what any of the chunks are of data that are going up into your cloud, and only the clients can know. The challenge with that is like, how do you limit storage space based on each group, right? Like I don't want a group to be able to use unlimited storage. I need to be able to track like, hey, your group is using 200 megabytes of the whatever 1 gigabyte I give you for free. So I need to track that, which means I need to have a concept of a group on the server. I can't rely on the client to just just tell me, you know, how much storage they're using in their group. So anyway, I basically have to have a concept of a group for that reason, which is just to have rate limiting per group, to have storage limits per group, things like that. But then do I need to know who the members of the group are? That's like an open question. So the easiest thing to do would be to know who the members of the group. The easiest thing to do would be to do no end-to-end encryption, which is why no one really does it for the most part, because it's very difficult to do for a service like this. But Yeah, I mean, I'd like to do it. It's a hard thing to do, and I tend to think that, you know, this sort of privacy, like you're building out a little space of privacy on the internet when you do these things, and so those spaces don't exist as much as I think they should, and it basically means you can't be yourself. I mean, you can. Yeah, I would say you probably shouldn't. You know, if you're going on Facebook and, you know, posting just about who you are and stuff, that can lead to issues one day for you. People don't think about that because life's been good for so long, but like I've talked about the other days, if you're in other countries, that's, you know, life hasn't, you might understand how valuable some of these rights are. It is a funny thing. Almost every person I talk to in the United States is like, wow, what difference does it make? Like, it's just crazy. It's like crazy how little people value their privacy. And it's like, oh, you don't get it. And that's why, like, I don't know, I don't want to get super negative so early in the stream, but like, I just don't see how things like World War III and stuff like that don't happen, because people just don't value enough how they don't understand how hard it is actually to maintain peace, to have rights, things like that. Like you're just so willing to give them up when life's been good for your whole life. Like when your parents' life has been good their whole life and your life has been good your whole life, you become very complacent. Maybe things like you've been better for some period of time, but, you know, at some point you hit a rough patch. It's like, it's just inevitable. And so, like, I don't even know if in my lifetime you really are going to need something like this. Like, maybe the US will be stable enough my whole life. Like, already the US is a little bit unstable, but maybe it stabilize. Who knows? You can't predict the future. The point is that with end-to-end encryption and sort of having privacy, you don't have to predict the future. You have the privacy, unless they literally stop the company from doing it and take that right away, which they could do. I mean, governments shut down Signal. The US could shut down Signal if they wanted to. Presumably they aren't going to do it. And my sense is the reason this type of thing doesn't happen is because the government and rich people particularly like spaces like this because they don't have them. So, you know, when Elon Musk has Twitter do end-to-end encryption, or Mark Zuckerberg has Facebook do end-to-end encryption for messages, the reason they do that is because they understand that they're how easy it is to get access to their data, and they don't want that. I imagine even in the cases where, like Facebook and Twitter, I imagine they still use Signal anyways, because they probably don't trust their engineers enough to, I wouldn't trust their engineers enough to implement these things perfectly correctly. And they're not audited. I mean, they hire security people to audit it, but how much do you trust the security people you hire? So anyway, my point is that end-to-end encryption is hard. There's a spectrum for how far along the end-to-end encryption world you can go. My general sense is I need to know what groups are. So when you upload a chunk, I need to know which group it's associated with. I don't necessarily want to know who's in the group, which is a little bit harder. That's basically what I have to do what Signal does, which is that when you upload a chunk to the group, you have to notify the other members of the group that a chunk was uploaded to the group. Because I don't know, I can't notify them. So you would basically create a message to each other person in the group saying, hey, you know, I posted something in the group. And so you would send to the server, some chunk of data, which is a post, an event, photo. The server would upload that chunk to that group, and or save that save that data to the chunk. And then after you had uploaded it, you would then send a message to everyone. So you would say, hey, tell this person this encrypted message, tell this person this encrypted, and in that message it would say, hey, you have a new notification, there's a new post that was posted. And so you could look at timings and stuff just like you could with Signal to see, like, you know, every time this person uploads to this group, they send a notification to these other 20 people. But then the other thing to consider is that even if you don't know who's in the group explicitly, so you could, one, look at like, hey, you know, Jeff uploads to this group something, and then he notifies these 5 people. So you could look at the timings. The other thing is that after those 5 people get a notification, they then go request the chunk. So, like, you know who's accessing that. Like, you can just not store logs, but what tends to happen, I think, with like VPNs and stuff is the government forces them to give them access to logs. So you can keep track of, you know, who's accessing the chunks. I was thinking about this, and what you can do is to avoid that, you can make the chunks. I mean, I was asking Claude questions and going back and forth with this. But the way you deal with this is you make the chunks public, so anyone can request the chunks. So that way the user doesn't have to be logged in or anything to fetch a chunk, and you don't pass the ID up or anything like that. All you know is the IP. So like an IP requests a chunk. It says, hey, I want this chunk. And you know that chunk is associated with some group, but you don't know who's behind that IP. So if the user wanted to, they could use a VPN. So every time they requested data about groups, you wouldn't know which user it was. There could be 100 users behind a single IP, things like this. And so this gives the user some way, if they need the privacy, that they can use Tor or things like this to access the service, and you wouldn't have information about them. Ultimately, for most users, they're going to just use their home address. You're going to have some information on who's in what groups based on the IP addresses that come in. You cannot store that information. If the government forces you to give access to the access logs to them of the IP addresses, then yeah, there's not much you can do about that. The government will know who's in what groups. They won't know what's in the groups. They won't know what the name of the group is, but they will know who's in the various groups. So that means if they catch one person doing something illegal or something, they can see who's associated with that person based on the groups that person was in. They won't know like which ones are doing what, or maybe that person was in like 20 groups or something, and maybe some of those were public or whatever. But yeah, the point is that it's very difficult to get rid of that aspect, as far as I know. I wish I knew anyone who knew this stuff better, and I might try to reach out to a couple people after I get a good plan down of what I want to do, and just see if maybe they'll give me some feedback. Ultimately, I think even if I were to keep who the members were explicitly and did end-to-end encryption, it would still be better than, I don't know, 95% of the more, almost every app you ever use. And it seems like I'm not going to be able to avoid the fact that you know who's in what groups. The only benefit to me is if I don't have the explicit user group list, I personally can't, like the company can't be subpoenaed for the list of groups. Otherwise, you're just constantly getting subpoenas for, hey, this person did something illegal. We see they're in these 5 groups. We want to know who's in those groups. And like, if you know, you have to just give them the data. You have to create this whole process for it. Whereas if you just have the clients know who's in the groups directly, and then like indirectly you could find out, that's not something you can really subpoena. The government, like I said, could force you to give them access to the logs, or force their way in whatever way they want to, but there's not much you can do about that. And so that's why if you don't know who the members of the groups are, then if someone wanted to be very secure, what they could do is everyone in the group could access the group through Tor, and then you wouldn't know who was in. You wouldn't know who they were. You wouldn't know what groups they were in. You wouldn't be able to track it. So that's the biggest benefit too. It gives you an ability to do that if you want to organize for some reason. Say you're in Iran and you want to organize. Of course, Iran will just ban it. That's kind of at the end of the day, that's the biggest trouble with any of this. You do all this, and then, they can just block it. It's entirely viable. But at least you know when that happens. Like, that right was taken away. So that's what I've been thinking about. Yeah, I mean, no one's watching right now. Maybe someone will watch it on the VOD. Maybe I'll watch. We're at 11:40. I gotta leave probably around 5. So I got a few hours. Today's like an organization day. I might come back to doing some of the front end stuff, but it's basically done. There's little things. That's why I started creating these projects. So I can keep track of the different groups of tasks. I was like, I don't know. I hate as soon as you start doing this, it becomes demotivating because you start getting this huge list of things, and it's like you gotta just ignore all of it. But I do need to keep track of like, hey, there was this thing or that thing, or like I'm gonna lose context on stuff as I swap between these things. So I need a place to just, when I'm doing something, keep tasks in there. And then some of my friends have been asking about, you know, if they wanted to suggest different ideas, how would they do that? So I was thinking, this works. You can submit an issue, and then I can add that as a task and triage it. And people can vote on it in the issues. So what am I gonna do? I'm gonna run out of tokens today, which is the other reason that it's like kind of just a planning day. So I think I'm just gonna relax. I'm not gonna worry too much about what has to get done today. I think I'm just gonna take it easy, organize some stuff. Today's a cleanup day. So I do need to commit all these changes. Maybe I'll go ahead and do that right now, which is add another commit. Git add git commit dash m temporary commit groups comments. I don't want to need to stop this. Verify. Right. Why does this one every single time? We've got a bunch of these temporary commits. I need to push these because I can't, if I lost this work, I would go nuts. I mean, I have video of everything, so it wouldn't be terrible to recreate it, but it would not be fun to recreate all this. I was looking at the videos, and it looks like I've spent about 50-ish hours, 52, 50 something hours building this. I don't know if it feels like a lot or not. There's also like some time where I take like little breaks to take the animals out or give them food and stuff. But then also I've spent time kind of outside of this just thinking about it a little bit, so I think those kind of cancel out. That 50 hours, like if I think about, how many hours would it take at a company? It's not like a week and a half of work or so. Like it would probably be a month of work, and that would be like if you were able to just not have other responsibility, like because assuming you're working 8 hours a day, you like have lunch, people talk to you, you have interviews, you have to get to work, you have meetings about stuff, you got to explain to people what you're doing. I would say like maybe I could get this done in a month at a company if I like was allowed to just, if they were like, hey, you just go do this and then show us in a month, I could maybe do it. It would have to be like in a separate repo too, because you would want to avoid the build tooling. There's no code, you can't do code reviews or anything. A month is like basically letting me do the same thing, but there's people around and a company sort of setup, and maybe I have some other slight responsibilities. Yeah, it's just interesting. 50 hours of work. I mean, this was essentially a week and a half for me. Week and a half. I think I started a week ago. So I'm pretty happy with this. It's just, yeah, how long would it take to build a company? And now the annoying thing is like, I got to get this done because copying it would be much easier. So now that it exists, to like make a clone would be pretty fast. But my expectation is that if I could get this done in 6 months, I'd be pretty happy. That's kind of like I could keep up the current pace and not have too many distractions. If I could get this done by summer in a way that I was happy with, I'd be pretty happy. But it's hard to maintain 6 months at this pace. I'm already starting to burnout of energy. All right. Let's see what we're doing here. We committed that. I created all my tasks that were up here in web frontend. It's hard to know how much to break these things out. I was thinking like for infrastructure, do I break that down into like database, you know, Kubernetes, stuff like that. But I think for now I'll just do infrastructure, and then I can break it out more if I need to later. But then there's like web front end. Like I could just do front end, but then I'm going to have apps. And I feel like a lot of these tasks are very specific to the web interface. So, and then I do need kind of some ideas. I think end-to-end encryption was one of the major things I wanted to think about today, like specifically what trade-offs I want to make and how I'm actually going to go about implementing that, because I do think the next thing to do is to start doing the back end. I need to get like a backend set up, and then I think I should get a deploy process set up for both of them as well as testing. And the backend will be much more straightforward for setting up testing and deployment. So I'm going to do that one first. And then once I have that kind of pipeline in place, I can start to adapt that to the front end as I integrate the front end with the back end. What am I thinking? I'll have to like deal with setting up Vitech, because you still need a database. Even if everything's end-to-end encrypted, I'll still need a database to keep track of the groups and how much, like which chunk belongs to which group. So yeah, one thing I was thinking too with like images. So probably I need to have users upload images to a storage service, like images and videos and stuff, maybe. Something I got to think about. So you can encrypt the best thing to do would be to put the videos and from a privacy standpoint, I think would be to put the videos and photos like into the data for the group itself. But the alternative is you have a user upload it to a storage service like S3 encrypted, and then you just include a link in the message, and then use the same encryption key for that object. I might do that. I got to think about it. Once I get there, that's a trade-off I'll have to figure out. My goal right now is like, could I just get basic messaging working with the sort of format I'm thinking, like where you can do posts, maybe you can DM people. And I need to get this like chunk rotation set up. So so you have a group ID, and so you have chunks of data associated with the group ID. I'm calling them chunks because I'm gonna rotate keys periodically, or as the chunks grow past a certain size. And I'm gonna rotate keys because if I need to delete a chunk, say if the group has a gigabyte of storage, imagine you invited 3 people and you used up your gigabyte of storage. If I stored that all as a single chunk, I can't delete. I'd have to just delete your entire group's data in one go. And so I need to chunk them in like, 20 megabytes, 50 megabytes, something like this, and then rotate keys periodically every time that happens. As well too, if a new person joins or a person leaves, you need to rotate the keys and create a new chunk. So all the data going forward from that person leaving or joining are in the new chunk. So key rotation is going to be something I got to deal with. And that's what I got to look at some of those algorithms. I was looking at like TreeCam, MLS. So there's like TreeCam and MLS are some of these newer messaging protocols. I need to look at the scaling factors for these. And it probably depends, like even if the scaling factor is better, it might be worse initially. And like if all your groups are say 10 to 100 people, you might use something with a better scaling factor past 1,000 people, but it might still be worse for like if your average group is 10, you might be better off just like limiting groups to 1,000. And you might have some groups that are large, but still it really depends. It's very specific. It just depends, like, do you need to support a 50,000 person group, 100,000 person group, or do you need efficiency for small groups? because those are going to necessitate different algorithms generally. Yeah, I was asking a bunch of questions, like, for example, when you do a key rotation, how does that actually work? Because if the server doesn't know who's in a group, and you're like, hey, this chunk is too big, you can't write to this chunk anymore, what you need to do is you need to basically have the client trigger the key rotation for the other members in the group, because the client knows who the other members in the group are, but you as the server don't. So the server can just set a flag basically saying, hey, you can't write to this when the client fetches. When the client tries to write, you need to reject it and tell the client that they need to rotate keys and create a new chunk. So then the client will have to create the new chunk, tell the server to create the new chunk, or I guess they'll create it themselves. I have to think about it. And then they'll send out the new key to all the other members. So you encrypt the key with each other members' public key, so they all have access to it, and then the client will upload that set of keys, encrypted keys, for that chunk to the server, and then all the other clients can start accessing it. But so anyways, if the server doesn't know who the group members are, they can't trigger the key rotation. They can't tell the members that they need to rotate. One of the members has to do it. Then you have all sorts of issues about, like, what if a member's phone is offline and do they get the key? Do they know the rotation needed to, you know what I mean? And so there's all sorts of different ways you got to deal with this. Like I think one thing to do would probably be to make the last message of any chunk the keys. Then when the clients fetch the latest chunk, they also fetch the new keys. The alternative way to do it would be to have the client directly send the keys to each other member. I think the best way is to do this is adding it as the last message in a chunk. Should always be the keys and the location of the new chunk, or the ID of the new, whatever it is, the ID of the new chunk. So then the members, they can just fetch it, and otherwise I have to deal with the fact that mailboxes, like, you can when one of the clients is going to try to write a message to the server, and the server is going to say, hey, you can't write this message because it's full. The chunk is full. You got to create a new chunk and rotate keys. And I could have that client send the other clients their keys, send a message to them. If the other clients, the recipients of those keys, maybe they're like on a vacation for 3 months and they're trying to like not have their phone on, or maybe even a year. Like, I can't keep the message for them for a year, because you need to filter out the messages in the mailbox after some period of time. And because you don't know like what's a key message and what's a media message or anything, you can't like keep the key messages around for a long period of time. So you can't keep it in the person's mailbox. So I think it has to be something where they pull, using their key, they have to pull the last message from the group chunk, and then now they have access to the next chunk. Yeah. And the server still doesn't know who they are. Yep, I think that worked. Okay, how am I gonna do this? Do I take a note down? What do I do? What do I do here? I gotta write some of this stuff down, otherwise I'll forget. Just in case. Okay. So I've got projects. I need to create the plan. Do I want to do that in Notion? Do I want to do that in Obsidian? Notion's probably the best thing. Notion? I don't know. I hate documents these days because so much of it's like AI generated stuff. So I don't want a Notion document where I'm like putting in AI generated stuff. I just need to keep track of the core decision points. How do I do this? It's such a big decision space. And then like the decisions you make for the end-to-end encryption, that's like just so you know how you have to architect everything. Like you still don't even like then you got to write the code that even does that, which is a totally separate thing. Okay, let me think. Let's do Google Docs. I think Google Docs is going to serve us better. Do I want to do my public Google Docs or do I want to do Kiwi Research Google Docs? What do I want to do? I tried to have this make me an outline yesterday of all the decisions. Good job, Google. And then it asked me these questions, and I was like, I gotta really think about these questions. Let's see. What do we think? Google Docs or Notion? This is annoying me. Cannot make a decision. The other issue is I have like Kiwi Research is the old organization name I was using. I don't mind to continue using it, but it has really nothing to do with happy groups necessarily, which is fine. Yeah, fuck it. We'll do Kiwi Research, new document. But yeah, then the other problem is that the documents, the default layout of the Google Docs is so ugly. I remember spending so much time making this look half decent. Okay, I don't have time to worry about this. I gotta do other stuff, so. Let's be auto capitalize. What does the server know? I'm just gonna do this. We're here. Push notifications. Do you want them? So 1. Yes, I want push notifications. 2. Not sure on group size. Probably most are small, less than 20 people, but maybe want to support large groups. Not clear if TreeChem or MLS might be good. And not sure, well, how efficient, not sure how efficient those are for small groups. 3. Media images. Yeah, so do you want media images, media files to be inside the group chunks? Or should they be links? Should they be encrypted and uploaded to a storage service? That would mean rotation would have to happen less often. So if the user needs to upload an image or a video or something, and you encrypt that and you upload it to S3, and then the user encrypts the URL and puts that in a message which goes into one of the groups, you as the server don't know who you don't know which each bucket goes to which group, and so you can't account for that unless you basically require that when the user uploads it to the storage service, they also have to tag which group it belongs to, which I guess is not unreasonable. So you would have to encrypt the image or the video, upload it to the storage service. The storage service would tag which group it's associated with. No, it doesn't help you. You would have to know which group and which chunk it was associated with. I think it's better to just encrypt the images and video and put them into group chunks directly. It's just a pain because assuming you want to chunk the groups my audio stopped again. Assuming you want to chunk the groups every like 20 megabytes or 50 megabytes and rotate keys, then if someone uploads an image or a video, you have to do aggressive compression, which is what Signal does. And it's pretty annoying. Like it's not a good experience to have such aggressive compression. But the thing is, like, even if you upload it somewhere else, you still need to account for how big chunks are in the storage space. If you know which chunk each thing belongs to, let me write this down. So let's say each group gets 1 gigabyte. 1 gigabyte? That's a lot. That's fine. Storage space. Let's see. Good job, Google. Can't play audio. So let's say each group gets 1 gig of storage space. You want to rotate the group chunks periodically so that if the group is going to exceed that storage space, then we need to delete old chunks. Optionally, they can pay storage. To delete, all the chunks are encrypted. So we don't know. All the chunks are encrypted, so we don't know what's in them. To delete old chunks of data, we do know. What is that? Are you kidding me? We do know which chunks of data belong to which group and which chunks are the oldest. The thing we need to avoid is a group hitting the 1 gigabyte limit and us having to delete the entire group's data because it's in a single chunk. So let's say each group gets 1 gig of storage space. You want to rotate the group's chunks periodically so that if the group is going to exceed that storage space, then we need to delete old chunks. All the chunks are encrypted, so we don't know what's in them. We do know which chunks. Rotate the group chunk. We need to periodically chunk the group's data and rotate keys. This all data, all the group's data is encrypted, so we don't know what's in it. You want to periodically chunk the group's data and rotate keys so that if a group is going to exceed that storage space, then we can delete the oldest chunks. We do know which chunks of data belong to which group and which chunks are the oldest. The thing we need to avoid is a group hitting the 1 gig limit and us having to delete the entire group's data because it's a single chunk. The thing we need to avoid is a group hitting the 1 gig limit. So now the question is, do we store rich data inside the chunks directly? Images, videos. Or do we encrypt, upload them to a storage service along with some metadata about group and chunk ID? Does this do anything for us? I don't really think so. I don't really think so because we're still going to just have to rotate. Because let's say the user uploads a 100 megabyte video. We're still going to have to rotate whether it's directly the group data chunk. If it's storage. And it seems like storing it in a separate service complicates deleting the oldest data. Have to rotate. Let's see. I wish I could use the context here and ask a different question and then come back. They don't have good branching here. It's like the thing Theo's thing does better. I'm building an encrypted. Let's add a little thing at the top. I'm building an end-to-end encrypted groups app Groups will be small. All the group's data is encrypted, so we don't know what's in it. You want to periodically chunk the group's data and rotate keys. The server wants to avoid knowing who's in what group. It will know what data belongs to which group and how much. I think that's enough information. So let's say each group gets 1 gig of storage space. All the group's data is encrypted, so we don't know what's in it. What do you think about this? The real question is, what's your unit of deletion? With everything inline in chunks, your deletion granularity is a chunk. If chunks are time-based and user uploads a 100 megabyte video, you either force an immediate chunk rotation, now you have a tiny chunk and a video-dominated chunk. Treat the storage model as a single ordered queue of deletable units, where message chunks, small fixed message metadata and small inline content, media blobs, 1 per media item, any size encrypted. Both have timestamps, both count towards the 1 gig quote. When you need free space, you delete the oldest units, regardless of type. I see. Yeah, you would keep a separate stream of chunks. Message chunks stay reasonably sized. You're not forced into weird rotations by large up. You just maintain one ordered list. Just needs to know the order. The server already knows which blogs. I agree with this. How would the key rotation work? The media block. I guess the keys for separate chunks. My idea was that every time you had a new chunk, you rotated keys. But if a single media item is chunk, probably don't want to rotate keys every time that happens. So keys would no longer keys and chunks need to be disabled. Yep. Yeah, model key up. Keys are tied to time here. Chunk it. Yep. If you delete old messages, but a user pinned an old, keep that epic's key. So complicated. Not the keys nor the content. ID group wants to prevent the user from content with server doesn't know the keys, but it does know what the current ID is. Group. So on upload, the server just rejects anything where epic ID. Or you need to decides when epic wrote. Client signaled. Client tells. Either way, epic transitions are explicit events this. About a malicious client encryption. They claim epic 5, but actually encrypt with key 3. Server can't detect. Doesn't matter. Other clients will try to. Hacker only corrupts their own. A removed member uploads backdated content. So, also thinking about separating Weighing the benefits of segregating metadata from messages. Great question. Metadata is really different. Metadata was encrypted with epoch 1's key. The upload must. Now I wonder how Signal does admins? Are there different keys? Like, how does that actually work with encryption? Metadata upload must use current epoch. Current epoch's key. Decrypt. Do you think it makes more sense? Do you think it's worth keeping the old versions around? So basically we have a stream of chunks of data. Blob ID, group ID, epoch ID, timestamp size. This is all we know. The clients need to know which blob to write to. Just keep the latest. If you keep the old, you need the old keys. Now you can't. How do the clients know which blob to write messages to? Like if they're creating a photo, they always is it? Guys, create a new blob. Should we do the same thing for messages? But then we know the message count. Message count. How do the clients know which blob to write messages to? Like if they're creating a photo, they always create a new blob. You write to some current message blob. Then how do they know which one? Okay. Epic. And then the open question is, it's a coordination problem and it's tricky. 1 blob per message, simple, no coordination. Server knows message count and timing. Client needs to coordinate. Read, append, write if unchanged, reach out conflict. Per sender blobs. Each client writes their own stream of blobs. Readers merge by timestamp. Although maybe there's something missing here that it's not explaining. So each time you write a message, so every time you write a message, photo, video, whatever, that's a new blob with an associated group ID, epic ID. Group ID, epic ID. When rotation happens, can we maybe make it the case that the last message in any epic is the for the next epic? The encrypted keys for the next epic. We can't really ensure that happens, right? Because the client is the only one. It would have to be some message that server parse in some way to make sure it was correct. Some kind of keys, sign each. But then we need to know the members. I'm just wondering that this rotation setup would allow clients to brick the group going forward by failing to actually write the keys for the next epic. Let's see. Every time you write a message, maybe I'll do this. Move this over here. Every time you write a message or photo video, there's a new blob with an associated group ID and epic ID. When rotation happens, yeah, liveness problem. When embedding keys in the message stream is awkward. Why embedding keys in the message stream is awkward? For the server to verify this is a valid key distribution message, it would need to know who the members are, their public keys, that each member got a key, which defeats your privacy goals. Yeah, so it's like you have some period of time where you have an epic that uses key, like the group's keys, the group key to encrypt all the messages in that epic. Then you need to rotate. So every member gets a new key. It's all the same key for all the members, but it's all signed with their public key. But for the server to ensure that that happened, then the server needs to know who the members are and what their public keys are. Otherwise, the client that triggers the rotation could just brick communication for all of the other members. Signal avoids this because you don't actually control the communication keys for all the other members. Like, that's all independent. There's no single group key that everyone uses to encrypt stuff. So the issue is I want shared history for the group so I can keep track of the storage space and limit the storage space. I don't want everyone to have their own version of each message encrypted, which is how Signal works. Everyone has their own history, and everyone sends every message encrypted for themselves. The thing is, Signal doesn't store any history, so it doesn't really have an issue with the storage, and that cost basically gets spread onto all the users, onto their devices. So in my situation, I want to be able to keep the history on the server as a single copy, and everyone needs to be able to access it and write to it. To do that, I was going to do a shared key that rotates periodically. So even if you were able to break the encryption or whatever for a single epoch, you wouldn't have access to the whole group's history. But every time you do a rotation, you need to change that epoch key. So some client needs to decide, hey, we're going to do a rotation. I'm going to create a new private key. I'm going to encrypt that private key with every public member's ID, public member's public key, every other member's public key. I'm going to send it to them. Or I'm going to post an encrypted blob somewhere with all of those, maybe in the previous epoch. And so you can post it in the previous epoch so all the members could see, hey, there's a new epoch, and let me get the key out of it. Let me get the key out of the current epoch to use for the new epoch. But the problem with that is that the last message that the client needs to attach to the previous epoch is, hey, here's the keys for the next epoch. But the server can't verify that in any way because the message is encrypted. So it'd be very easy for a client to just brick the entire group so that they couldn't post any more messages. And then maybe you could limit it to like the owner of the group is able to do the key rotation or an admin of the group is able to do the key rotation. But what if neither one of those is signed in? Like what if, you know, they all go on vacation and you're the only person left or something, who knows? Then the group eventually just dies if you don't allow rotation from by all the members. So Signal's model is really nicer in this regard. Because in Signal's model, when you are in a group chat with 5 people, you just send messages directly to those 5 people and you each share a key, but just pairwise with each other member. So like if one member decides to screw something up, they're only screwing up their own messages to the other people. They're not screwing up anyone else's messages because there's no shared key. No group shared key. Yeah, I don't know if there's a way to deal with this. Why embedding keys in the message stream is awkward. For the server to verify that this is, yeah, I would need to know. Separate the concerns. So like if the server knew who the members were and stuff, then it could see that the last message was, hey, here are the new keys and here are the user IDs for each key, and then the members could fetch that. But even still, like, because this is client-side controlled, it'd be very possible for someone to exclude one member going forward by giving them a fake key for the next epoch. Separate the concerns. Server knows epoch 5 is now active for group X. Key distribution. How members actually get the keys. For time-based rotation, deterministic derivation. They don't have to be the same mechanism. How members actually get the keys. Any client with the current key can derive to the next one. That's interesting. I like that. So key n plus 1 is equal to key distribution function. Key of n, epoch, n plus 1. Yeah, that would work. But then you would have to have some other rotation that happens when someone removes someone. So you'd have to have two different mechanisms for doing rotation. You'd have to have a mechanism for doing key rotation when it's time-based. So everyone who's in the group, they would all be able to do this as long as no one's removed or added. And then basically the source key would need to change every time someone's removed or added, which could only happen from admins. So an admin could brick the group if they wanted to. For membership changes, that's the hard one. So when someone is removed, you need a truly new key that removed member can't derive. This requires explicit distribution. But here's the insight. Any remaining member can do the distribution, not just one designated client. Here's the insight. Any remaining member can do the distribution, not just one designated client. The membership list is in the encrypted metadata. Anyone who can read it can generate and distribute new keys. Recovery-friendly model. Key bundle lives in a separate blob. Group keys epic ID contains encrypted key. Any member can write or overwrite this blob. If someone starts a rotation but disappears, another member notices. Can't decrypt new content. All members who know the old key go offline permanently. Group is dead. Malicious member distribute. Yeah, that's what I'm wondering about. Malicious member distributes bad keys. Other members can overwrite with correct ones. Malicious member distributes bad key. Other members can overwrite with correct ones. This is so complicated. Oh, what a pain. Let's see. Explain this more. Let me walk through the scenario. Carol gets removed from the group. Epic rotates. Someone needs to distribute the new key. Alice, malicious but still a member, takes this responsibility. Alice generates key 5, encrypts it directly for herself and Charlie, but gives Bob garbage. Bob tries to decrypt new messages. Gets gibberish. Bob notices he can't decrypt. Bob signals this somehow. Maybe posts in the old Epic. I can't read Epic 5. Charlie sees this, thinks, that's weird. It works for me. Charlie re-encrypts key 5 for Bob's. Oh, that's. Yeah, so any other member. So basically anyone in the group could post. So if someone tries to block everyone else from the group. Yeah, let me see if it goes over that case. Which is what if the person does the rotation and doesn't write it for anyone? So then literally no one can get the new key. They would all have to override it or something. Key bundles are mutable by any member, not just the original author. Member public keys are available. Bob can notice and signal the problem. At least one honest member is online. If Alice is the only other member, Bob is screwed. Deeper question. Who's allowed to generate new epic keys? Anyone? Admin only or threshold? Yeah, it's a lot more complex to do K of N. So you'd have to have some kind of consensus for generating the new key. I'm wondering about the case where Alice. Blocks generates garbage for everyone. So that she is the only one who can That's worse. Now there's no one to fix it. The attack. Alice generates key 5, encrypts it quickly only for herself, garbage for everyone else. Server accepts this. Server enforces Epic 5 only for new uploads. Everyone except Alice is locked out of writing and reading new content. Other members still have Epic Key 4 and can still read old content membership list, but can't coordinate an Epic 5. Bob and Charlie could generate a different key 5 and overwrite Alice's bundle, but Alice can overwrite it back. Even if they win the race, anything Alice encrypted with her key 5 is lost. It's a mess. 2-phase Epic activation. Alice uploads key bundle for Epic 5. Epic 5 becomes active only after K members act. Server tracks Epic 5 status proposed, confirmed. Required acts. I like that. So you basically allow anyone to trigger the Epic rotation and generate the private key. But if someone were malicious, they can't just shut down the group by themselves. They would need some amount of people. And you could also only allow admins or the creator to do that. But I think for small groups, that's not really viable. So I think this approach works better. This stuff gets complicated though, because the reason Signal's better. What is she barking at? Hold on. Probably a deer or something. So the reason this is like worse than the way Signal works is because you have like a certain number of members that are needed for this to work, right? So imagine I'm an admin, and as an admin, I can just add members to the group. So if I wanted to shut the group down, I could just make like 2 or 3 more accounts, add those accounts to my group, and now I can bypass the act requirement, the number of acknowledgers of the Epic rotation. So yeah, I mean, this doesn't even really help you that much. If you're an admin, you can effectively just shut the group down. Which isn't... I guess if you're an admin in Signal, you can just remove everyone. You could remove everyone else, so... If you're an admin in Signal, can you effectively just shut the group down? Can members of a group add other members without being an admin? This is complicated. Signal, who can add? Probably only admins can add members to a group. Admins controls to remove a member. Controls who can edit group info. Optional admin approval for members joining. Create a group on Signal. You can invite people to a group. Also require admin approval if someone requests to join. So what happens if you don't require admin approval? Then anyone can just join your group if anyone else in the group wants to, I guess. But you can remove them, but then the person could just add them back if they wanted to. In Signal, only admins can optionally require approval to add members to a group. If they don't require approval, then other members can just add new members. And I guess the admin can remove them if they want. Then the user just add them back again. The removal loop you're describing. Admin to remove someone, another member can just add them back. Change the add members permission to only admins. Okay. I guess you have forward privacy, so even if someone adds someone to the group, they can't see the history, so it's not really a big deal, so you can remove them fairly quickly. But in the case that you're doing this kind of, in the case you're doing this sort of ACK requirement thing, then having members be able to add other members means any member can just brick your group going forward. In Signal, that's not possible. You can only brick your own messages to other people in the group. Is there any way to avoid single malicious member because in the case that you've described, a member could just pack enough people to bypass the ACK requirement. In Signal, a member can only brick their communication with other members. They don't have any impact on the communication between other members. Is there any way we could do that with a shared history? In my head, the way you would do this is you would basically, every time someone uploaded a post or a photo, you would have to encrypt that post or photo with every other person's public key and your private key. And so every single time you uploaded a post, it would scale with the number of members in the group, which is how Signal works. But yeah, I mean, it's just not viable for storing on a server. But it would get around this issue. Then the other obvious thing would be to require every member to acknowledge. But what happens if a member's offline? It's not practical. The core problem, shared group key equals single point of failure. Whoever distributes the key has power over everyone. How Signal avoids this, sender keys. Each member has their own sender key that they control. Key distribution happens over pairwise channels. Alice sends her key to Bob directly to Charlie, etc. And Charlie sends his key to Bob directly, so that Alice can't impact Bob and Charlie talking to each other in that group. If Alice distributes garbage, she can only break her own outbound messages. Bob and Charlie still have their own sender keys distributed over their own pairwise channel. The communication is fine. Adapting this to the shared storage model, blob, group ID, sender key ID. Each member ratchets their own sender key forward periodically. Key distribution is pairwise, not groupwise. Member remove everyone except that rotates their keys. No single member. In this model, you need to encrypt the blob pairwise. So you have n copies for every stored on the server. How it actually works. Alice generates a symmetric sender key. Alice distributes that key to Bob and Charlie. Oh, because all my messages are independent now. Alice generates a symmetric sender key. Alice distributes that key to Bob and Charlie over pairwise channels. Yep. Alice encrypts her message with her sender key. Bob and Charlie both have her sender key. Both can decrypt the same blob. Yep. Key distribution O of n. Okay, this will work. Key distribution is expensive. You have to do it often, but that's the price. The price of privacy. But this is doable. Storing O of n is not doable. Distributing keys O of n is doable. When Alice joins, creates her first sender key. When Alice rotates to new members. Okay. So, do we have a concept of epics in that case anymore? What did it do up here? Sender key ID, sender ID. Each member ratchets their own sender key forward periodically. Sender keys specifically designed. So you have blob, sender ID, sender key. Do you need, does the server need I guess, yeah, you need to know sender ID. No. Yeah, I don't think you need to know sender ID and sender key ID, because you're going to have a list of keys associated with your group, and you can just look up that key. Like, you either have the key or you don't. I guess you need to know. Stop it. I guess the client might need to know the sender ID to request the key if they don't. Yeah, because if the server only has the key, and they don't know who the key belongs to, who it's for, which sender, then the client, they might get that message, and if they have the key, it's fine. But if they don't have the key, they need to know who to request the key from in the group. And if there's no sender ID, they have no idea whose key it is. So each sender has their own key lifecycle. Sender 1 key, sender key 2, sender key 3. Yeah, and so in this model, you tell the client it needs to rotate its keys or whatever. It could not rotate its keys, but it's only it's only harming itself. So like if Alice updates her client so that it's not going to rotate its keys anymore, every communication Alice has with anyone else could be at risk. But that's just, I mean, yeah, if that person chooses to do that, there's nothing you can do about it. But they can't affect anyone else. Yep. Just delete that by timestamp. When you delete old blobs, clients can delete the corresponding old sender keys. Still works. When you delete old blobs. What about cryptographic deletion? Still works. If all blobs encrypted with Alice sender key 1 are deleted, Alice deletes that key. That content is now unrecoverable even if blobs leak from backups. Yeah, this is what I was saying. So the issue is when Bob gets a message, he doesn't have the sender key, he doesn't know what to do. Who owns ABC123? You would have to ask everyone in the group whose sender key it is. Server already sees who uploads to which group. So it is not sender ID because Bob could send a request to each member asking who owns the key. Yeah, that would work fine, because what happens is when Alice generates her new key, she sends it to everyone's mailbox. 99% of the time, that works totally fine because a person signs on within a week or what, like just, they're gonna get the key. If they don't get the key, and Bob sees a thing he can't open, then Bob can just send everyone in the group, hey, whose key is this? Yeah, Bob rarely lacks a key. New member join needs everyone's current sender key. One rotates. When Alice rotates, she proactively pushes to all the members. Yeah, that's what I said. Now the ask everyone path is just a fallback for edge cases. Miss key distribution race conditions. What the server sees without sender ID. Sender key ID. Yeah, so the server just knows that this same person wrote these blobs over this time period, and then the key changes. They don't know who owns that key the next time either. There's a new key every so often. Okay. Yes, I like the only having the sender ID on the server. Alice would push to everyone else's mailboxes, which would persist some period of time. If that fails, then Bob receives a an sender key. Sender key doesn't know. Then he sends everyone in the group request for that key. Is this music? This is not a dolphin. That song is called. Like only having. Let me make sure I'm following the full picture. Mailbox model. Recipient pseudonym message ID. Alice rotates her sender key. Alice generates a new key with a new random sender ID. Alice encrypts key for each member's public key. Alice generates a new key with a new random sender key ID. Alice encrypts key for each member's public key. So pairwise for every other member. Alice drops encrypted key into each member's mailbox. Mailbox entries expire after some TTL. Yeah, or size. Your mailbox gets too big, you drop it too. Bob sees unknown sender key ID. Bob looks up group membership from encrypted group metadata he already has. Bob drops who owns sender key ID into each member's mailbox. Alice sees request, responds via Bob's mailbox. Bob gets key. Caches it. So, my open question is, how do you, let's say you log into a website where you have none of the history. Yeah, you have none of the keys, and you log in, and now I want to be able to fetch all the history. I need all the keys. How does that happen? Are mailbox pseudonyms the same as group membership pseudonyms? Are mailbox pseudonyms the same as group membership pseudonyms? The group, the server doesn't know, doesn't have pseudonyms, pseudonyms. Two. How does Bob know the membership list to send requests? I have a question, which is, when a user signs into a new device, I want to be able to pull the history for all the groups they're in. In order to do this, I need the encryption keys, the sender key, all the sender keys for all the members of every group they're in. How could this work? So when you log in, you would have to get the sender keys for every single other member in the group, plus any rotations that are still valid. You would need all of those sender keys from all the other members. Which means you would log in and then you would need to like ping, say, hundreds of people to get the sender keys. And each one of those would have to give you like multiple. On history sync to new device. This is the hard part. Options. Option 1, user maintains their own key vault. Vault/Alice identity. Yeah, so each member could have their own keys encrypted. User maintains their own key vault. Yeah, I think that's how it has to work. So you basically have a single password or like passkey or something that gives you access to your vault. This is a weak link. If someone gets access to this, you're screwed. And this is kind of the problem that Signal tries to avoid too, because this is really the honeypot for if you were trying to compromise someone. You would just try to compromise this, and then you would have access to all their messages. It would defeat the entire point of everything else. You do all this work to rotate keys and stuff like that, and it's like if I just get access to your account, I can access every single group you're in, basically. So you would like to avoid that. This is true on your device. Like on your device, you essentially have this. So like if you're in Signal, this exists for you on your phone in Signal. They would have to get access to your phone. There's nothing you can do about that. The issue here is that if it's on a server, now the server has a record for each user. Essentially that gives a bunch of incentive for like a government to go after that server or company or whatever, because they know if they can just crack the encryption on those keys, then they can read anything. The thing with the key vault is you wouldn't know which key belonged to which user necessarily. So you wouldn't know which key to try to crack the encryption on. But yeah, it's just not ideal. I don't know if you can do anything about it though. Every time Alice receives a sender key or rotates her own, she updates her vault. New device pulls, vault, decrypts, has everything. Vault can get large, every sender key from every member across all time. Vault can get stale if Alice is offline with keys ready. Vault can get... That's not a problem. Who encrypts group metadata? How does this work in Signal? Like, how do you actually get the list of members in the group? And what happens if someone's offline? When a new member joins? For Signal groups, how do new members get the group list? In Signal's current implementation, new members receive the group member list through the following mechanism. Encrypted group state on the server. Signal stores encrypted group metadata, including the member list. Is that true? signal when a new member is added, an existing member with appropriate permissions adds the new member's identifier to the existing member. Adds the new member's identifier to the group state. The inviting member sends the new member the group master key. With this key, the new member can fetch and decrypt. What happens if there's no admin creator online when a member writes on? Who adds a member to the group list? I guess everyone is able to have a new member. The inviting member fetches the current encrypted group state. They create a new version of the group state with the new member added. They submit this update to Signal Server. Server replaces the old group state with the new one. Signal Server can verify the change is authorized without decrypting the group data. This uses zero knowledge proofs. Server can confirm this change was made by someone with permission to add members. Server never sees who the members are or who was added. And Signal and confirm that no one was removed without correct permissions. Signal servers can verify removal authorization without seeing the actual member identities. When someone submits a group state change like removal, they include a zero knowledge proof that demonstrates I am a current member of this group. I am an admin of this group. The new group state encrypted with the group key. Server can verify these proofs without learning who the members are, who was removed, who submitted the change. What prevents unauthorized removal? If a non-admin tries to remove someone else, they can't produce a valid proof of admin status. The server rejects the state update. This is so hard. Signal has a dedicated library called ZK group for these zero knowledge proofs. Let's see. What is this? Called ZK group. There's no info on it. Yeah, I'm not going to be able to figure out what's going on here right now. So maybe I could use this. Cloud. Was it up? Okay. So, Signal has shared group metadata that's encrypted, where you can add and remove members and verify that only an admin did it, removed a member. Okay. Oops. Server doesn't need group membership. Yeah, so we'll have to maintain a key vault. Each member maintains their own encrypted key archive for that group. Option 4 doesn't give you anything more than option 1, right? Because you would still need to store the keys in the master vault or the group vault. I guess it would limit the size of the master. Under the user's control. You'd still need a master vault to know which groups you're in. The difference is just a list of group IDs, not all IDs. Make option 4. So it seems like we need group metadata. Something similar to GPT. And then we need master vaults and vault per user. Every message will be its own what is this? Every message will be its own blob with the sender key. And it can delete old messages individually when reaching the limit. Can you make an outline everything? Yes. And each group gets a storage quota. All content is encrypted. Server can't read it. Content is deletable individually by age to stay within quota. Blobs. Group ID, sender, key, time, size. 1 blob per message, photo, video. Couldn't get Claude to work. Okay. It did work though. 1 blob per message. Server knows group timestamp size, not sender identity or content. Oldest blob deleted first when quota exceeded. Yep. Sender keys. Each member maintains their own sender keys. Sender encrypts with their key. All members who have it can decrypt the same blob. 001 per message. Key rotation triggers periodic. After member removal. Key rotation. When a member is added or removed, you have to trigger everyone else to rotate their keys. What enforces everyone to rotate their keys when a member... Handled by client behavior and distribution. Group master key never rotates. It actually happens on removal. The removed member still knows it. It could theoretically decrypt. Is that true? So anyone who's ever added to a group can always find out who's in the group going forward? You could just rotate the group. I guess there's an issue. Sender keys. Each member's signal client is supposed to rotate their sender. The member is removed. Really enforced post. Why do you rotate? Is this the sender key? Did you? Everyone has access to decrypt the private key. You have, I guess, 3 keys. You have 1 key to write messages, 1 public key, and then 1 key to decrypt messages. And so all the other users get the key to decrypt messages. That gets encrypted with their public key and sent to them. And then they can decrypt it with their private keys. So when someone is removed from the group, you need to have everyone start using a new sender key. And if someone doesn't, the problem is that their messages will still be visible technically by the previous person. They won't be sent to them, but each member fault isolation. Alice rotates, generates new sender. Alice encrypts new key to each member's public key. This drops into each member's mailbox. Mailbox entries expire after time. Fallback. Bob sees unknown sender key ID. Bob looks up membership data. Bob responds. Group metadata. Group name. Description, settings, membership list with public. Always re-encrypted to current state. Server knows group. Groups. Encrypted to updated whenever keys rotate. And count towards the storage quota. Deleted when leaving group. What the server knows. Server knows group ID exists. Blob count size. Timestamps. Sender key ID per blob. Mailbox track. The key archives. Which key? GV2 style. Rate limiting, malicious. Pseudonym correlate. How does the user get access to their master? It could be password. Signal uses phone number. Identity. How does the server know who you are? How do you unlock the vault? These can be decoupled. Phone number. Familiar, hard to lose. Email. Takeover. Simple. Just for auth. Public key. Decryption options. Audio level. Decryption options. Password derived key. Familiar. Weak password forgettable. Recovery phrase. Device held. Nothing to remember. Lose all devices, lose everything. Pin plus rate limited server. Short pin is usable. Server prevents brute force. Signal SVR. That work. Signal secure value recovery is a system designed to securely store and recover user data. It uses Argon 2 to ensure that even signal cannot access the stored information. SVR enhances security by transitioning registration lock pins from easily brute force hashes. SVR stores encrypted data. SVR is used to strengthen Signal's registration lock feature, which prevents unauthorized. It uses Argon 2 to make pins more resistant to brute force attacks. The implementation has raised some privacy questions regarding the storage of data on servers, even if encrypted, particularly because it was introduced without extensive public explanation. At Signal, we want to make privacy simple. From the beginning, we've designed Signal so that your information is in your hands rather than ours. Technology like the Signal protocol secure your messages so that they are never visible by anyone but you and the intended recipients. Technologies like private contact discovery, private groups, and sealed sender mean that we don't have plain text records of your contact, social graph, profile name, location, group membership, group titles, group avatars, group attributes, or who is messaging whom. Plain text databases have never been our style. We don't want to build a system where you trust us through data. We want to build a system where you don't have to. It actually makes me think your profile should be encrypted too. I don't know how that works right now. Because anyone who had access to any of the groups you're in, they would have to be able to see your profile. The whole encryption thing, it's an entirely separate app from sort of a public version of this stuff. Pain in the butt. Okay. Plain text databases have never been our style. We don't want to build a system where you trust us with your data. We want to build a system where you don't have to. We've been working on new techniques based on secure enclaves and key splitting that are designed to enhance and expand general capabilities for public cloud storage. Our aim is to unlock new possibilities and new functionality within Signal which require cross-platform long-term durable state, while verifiably keeping this state inaccessible to everyone. Our aim? Yeah, okay. Cross-platform long-term durable state. Yeah, storing stuff on the server. While verifiably keeping everyone, okay. As long as you have your device intact and not, say, underneath the wheel of a car, you have access to all your Signal data. However, you may want to change devices, and accidents sometimes happen. The normal approach to these situations would be to store the data remotely in an unencrypted database, but our goal has always been to preserve your privacy. As an example, social apps need a social network, and Signals is built on the phone numbers that are stored in the device's address phone book. The address book on your device is in some ways a threat to the traditional social graphs controlled by companies like Facebook, since it is user-owned, portable, and accessible to any app you approve. For Signal, that has meant that we can leverage and contribute to a user-owned portable network without having to force users to build a new closed one from scratch. That's pretty funny. I was just talking to someone about this the other day. About how like data on social media platforms is not portable. And it's something you don't think about, which is that your address book is portable. And so that's actually a pretty valuable thing. You could imagine more of your data being portable, like which photos you had uploaded to Facebook and stuff. But yeah, just your address book is pretty valuable. For Signal, that is meant having a forest built from scratch. However, many Signal users would also like to be able to communicate without revealing their phone number. In part because these identifiers are so portable that they enable a user's conversation partner to contact them through other channels, cases where they might be less desirable. What is this song? One challenge has been that if we added support for something like usernames in Signal, those usernames wouldn't get saved in your phone's address book. Yeah, so they have usernames now, so you don't have to message people on Signal with their phone number. You can just use the username. But those aren't in your address book. Thus, if you reinstalled Signal or got a new device, you would lose your entire social graph because it's not saved anywhere when you're using usernames. Signal usernames. Other messaging apps solve this by storing a plain text copy of your address book, social graph, and conversation frequency on their servers. That way your phone can get run over by a car without flattening your social graph in those apps, but it comes at a high privacy cost, high privacy price. Remote storage can have local consequences. It's hard to remember now, but there was a period of time not long ago when the cloud hadn't yet become an overused catchphrase. In those heady days of yore, people used to store things themselves, usually only on one device and uphill both ways. What does that mean? Yeah, I think it just means before the internet existed, you would copy stuff on flash drives between computers. These were hardscrabble people living off whatever meager storage they could scrounge together. They'd zip things, put them on zip drives, and hope for the best. Then one day, almost everyone looked up towards the metaphorical sky and made a lot of compromises. The promise of the cloud has always been deceptively simple. You choose a provider, hope that you've made the right choice, give them your data, hope that they won't look at it, or sell it to advertisers. In exchange, you get to be a little bit more cavalier and careless. You're no longer one spilled coffee away from your unpublished novel, forever remaining unpublished. Your phone call can fall into a lake, and last year's lakeside pictures won't sink to the bottom. But connecting a bunch of unencrypted database to the internet hasn't been very good for privacy lately. There's 8 different articles. Hasn't. Data from Nokia intercepted by Russian telecoms. 100 million passwords from Quora stolen. Capital One data breach hacked. 50,000 Australian university students affected in data breach. Medical data of 1 million New Zealand residents. Data breach. DoorDash data breach affects millions of users. Pearson. What Pearson does? Oh, Pearson is the U.S. student tax. Pearson, I think, is the student loan company. There you go. Looking for silver lining. For a silver lining. Ideally, we could just encrypt everything that we want to store up there in the cloud, but there's a catch. In the example of a non-phone number-based addressing system, cloud storage is necessary for recovering the social graph that would otherwise be lost with a device switch or an app install. So if you have usernames and you're messaging those usernames and you have a list of those people, you got to store it in the cloud. Otherwise, if it's only on your device, then the device can get destroyed and you lose all of it. However, if the data were encrypted and the ciphertext remained safely in the cloud, the key to decrypt it However, if the data were encrypted and the ciphertext remained safely in the cloud, the key to decrypt it could still be lost with your phone at the bottom of the lake. Yeah, so you need some way to decrypt it. A password, fingerprint, something. They end up using a PIN, but the point is that if the key to decrypt it is on your phone, it doesn't matter that the contact list is in the cloud, encrypted. You can't access it. That means the key there has to be something you can remember or something that you can ensure will never end up at the bottom of the lake. Many readers will recognize the familiar trade-off here. Memorable passwords used with password-based encryption are often so weak that they are easy to brute force. Randomly generated passphrases strong enough to resist brute forcing are often too long to be memorable. For example, a random generated 12-word BIP39 passphrase might look like this. Stuff, plastic, young, air, easy. It's like 12 different words. That has a 128-bit security level, and the representation is probably better than 32 hex characters if you speak English, but it's still largely unrealistic for users to remember in everyday use. That means it's probably something users would need to write down and ensure it isn't lost or found by someone else. Not everyone wants to do that. Ideally, we could improve the situation for short, memorable passphrases or pins by making it harder to brute force them. One technique is to slow down the process of converting the passphrases or pin into an encryption key. Yeah. So you have some bad password or short pin, and you have to slow down how quickly you can attempt to convert that into the encryption key, so that an attacker can attempt so many different combinations in a given period of time. So if you can only do one combination every 10 minutes, then it's going to take you a long time to do a 8-digit passcode or something. However, there's a limit to how slow things can get without affecting legitimate client performance, and some user-chosen passwords may be so weak that no feasible amount of key stretching will prevent brute force attacks. At the same time, I feel like this is kind of a user problem. Like, you tell a user to use a strong password if they don't want to use a strong password, but I guess you put everyone else in every group that you're in at risk if you do it that way. So if you join a bunch of groups and people want to know that you haven't just used a two-letter password and everything that you're, every group you're joining is basically publicly accessible. Ultimately, brute force attacks are difficult to stop when they are offline, meaning that an attacker can cycle through guesses as quickly as their CPU or GPU will allow them. Secure value recovery is designed to additionally strengthen passphrases by preventing offline attacks through a constraint on the maximum number of brute force attacks guesses an attacker is allowed. Let's take a look at how to build such a system. This is interesting. Is it like initially the way I would think this would work is the server itself would be the thing that ensures how many attempts you can make. But the thing is that if that's the case, then a government or if someone was able to get on Signal servers, then they could just make unlimited guess attempts very quickly. So there must be something around that to get around that limitation. Stretching beyond a KDF, key distribution function, I think. KDF. I don't know. What is a KDF? Key derivation function. Okay. Starting with a user's passphrase or PIN, clients use Argon 2. Let's see what Argon 2 is. Argon 2 is a key derivation function that was selected as the winner of the 2015 password hashing competition. It was designed by Alex, Daniel, and Dimitri from Luxembourg. The reference implementation of Argon 2 was related under Creative Commons. The Argon 2 function uses a large fixed-size memory region to make brute force attacks computationally expensive. The three variants differ in how they access this memory. Argon 2D maximizes resistance to GPU cracking attacks. It accesses the memory array in a password-dependent order, which reduces the possibility of time memory trade-off attacks, but introduces possible side-channel attacks. Yeah, I think that one of the things I read before I started this article was how there was some skepticism, because it just seems really hard to prevent the ability to just do unlimited attempts to crack a password. I'm sure this is all smart and stuff, but it's just like on its face, it seems extremely hard to guarantee that. And so if everyone's using very simple pins to encrypt stuff, then if ever someone figures out some kind of attack, you can decrypt all of it, potentially. Argon 2i is optimized to resist side channel attacks. It accesses the memory array in a password-independent order. Argon 2ID is a hybrid version. It follows the Argon 2i approach for first half pass over memory. All three modes allow specification by three parameters that control execution time, memory required, and degree of parallelism. While there are no public cryptanalysis applicable to Argon 2D, there are two published attacks on the 2i function. So that's kind of the thing with this, right? Is like, if you use something like this and assume that this is going to protect you, presumably there are people who would not release the attacks that would crack something like this. You know, some security researchers will do that, but then you have governments that would just find vulnerabilities in this and not ever publish them. They would still need access to your servers to be able to do the attacks quickly, but let's see what this says. So Argon 2 takes a password, assault. Okay, this music is not working right now. Let's see. Tag length, memory size, iterations, version, key, I don't know. I'm gonna skip this for now. I don't need to know the details. Starting with the user's passphrase or PIN, clients use Argon 2 to stretch it into a 32-byte key. From this stretched key, we generate two additional variables, an authentication token and a master key. From the stretched key, we generate two additional variables, an authentication token and combined with a randomly generated info, the master key. The master key can then be used to derive additional application keys used to protect data stored in the cloud. Stretched key. Argon 2 passphrase, output length, the auth key, the master key. C2. Master key. C1, C2. Application key, take the master key, and then use that to create a public key. The application key to encrypt other stuff. And so you have to have the master key. Which key, master key? Create two keys, an auth key and a master key. The master key you use to create other keys. Notice the master key incorporates C2, 256 bits of secure random data, so an attacker cannot brute force it, regardless of the passphrase that was chosen. Likewise, master key incorporates all the entropy of the original passphrase, so it also remains strong even if C2 is compromised. Does C2 have to be stored? Does C2 need to be stored? I'm not sure. I guess so. So, if someone loses their phone, the stretch key, auth key, and C1 variables can be regenerated at any time on the client as long as the user remembers their passphrase. If you have the passphrase, you can generate the stretch key. You can generate these two. However, clients will need to be able to recover C2, the output from secure RNG, that's a secure random number, in order to reconstruct master key. We could safely store C2 on the service and authenticate access to it via auth key. It would be kind of like, what's the point? Why would you do that? Why would you like make another variable that you could just decrypt with the auth key? If someone was able to get the auth key, then they could just get this, so it doesn't really make your master key any more secure. It just makes it different. We could safely store C2 on the service and authenticate access to it via auth key. That would allow legitimate clients to fully reconstruct master key, but wouldn't allow an attacker who obtained access to the service to do so without knowledge of the original user passphrase. However, it would allow an attacker with access to the service to run an offline brute force attack. It would allow an attacker with access to the service to run an offline, yeah. Users with a BIP39 passphrase as above would be safe against such brute force attacks. Users with a BIP39 would be safe against such brute force attacks. Yeah, it would allow an attacker to run an offline brute force attack. But even with an expensive KDF, forget the abbreviation, key creating function, whatever it's called. Users who prefer a more memorable passphrase might not be, depending on the amount of money the attacker wants to spend. So yeah, if a user uses a small passphrase, it doesn't matter, you do all this work, they're going to be able to brute force it. Ideally, we could somehow limit access to C2 through an additional mechanism that doesn't allow for such offline guessing. Deus SGX Machina. SGX. Intel software guard extensions. Whether your goal is to, using the library libOS software guard extensions. Software guard extensions allow applications to provision a secure enclave that is isolated from the host operating system and kernel. Similar technologies like ARM's Trust Zone, SGX Enclave also supports remote attestation. Remote attestation provides a cryptographic guarantee of the code that is running in a remote enclave over a network. Originally designed for DRM, DRM for media content. Originally designed for DRM applications, most SGX examples imagine an SGX enclave running on an end user's device. This would allow a server to stream media content to the user with the assurance that the client software requesting the media is the authentic software that will play the media only once. So this is to prevent someone from like watching YouTube or watching Netflix and basically just copying the movie. Of course, good luck, but you can at least prevent the software from doing it directly. Only once, instead of custom software that reverse engineer the network's API call and will publish the media as a torrent instead. However, we can invert the traditional SGX relationship. The thing you can do with this though is that if you do it this way, what the media companies do is that they'll then embed frames of fingerprints of like who's watching the stream or which theater the movie's playing in. And so when you're recording it with whatever software, as long as they can ensure that they can get the fingerprints in there, which is basically what happens if they can run the software, when you record it, you would have to look at every frame and make sure you hadn't captured any frames with fingerprints, which no one's going to bother doing. So it gives them some way to do some kind of tracking. Of course, you could try to get rid of all the fingerprints too, but you have to find them. So Anyway, yeah, just side note. However, we can invert the traditional SGX relationship to run a secure enclave on the server. An SGX enclave on the server, yeah, so it's saying that the servers can run SGX code. An SGX enclave on the server would enable a service to perform computations on encrypted client data without learning the content of the data or the result of the computation. But something has to be able to get C2. So the enclave requests C2? Like, where does the enclave get C2 from? It's got to read it from somewhere. I guess if you write it to disk and it's encrypted or something, I don't know. there's got to be some way to get C2, and you would need it to always stay in the enclave and never leave the secure enclave. I don't know how you would do that. Let's see if it tells us. If we put pairs of auth key C2 inside an enclave and only allow retrieval of the value from the enclave, yeah, by presenting the correct auth key to the enclave. If we put pairs inside an enclave, I don't know what this means. I guess the enclave would have to have its own like storage device or something. Or I don't know. I just have no idea what that means. Like, I could imagine having a server that works like this. Like, you basically have a server that has a disk that only has these keys, and it can only run that code. So maybe that's what they had. Maybe they literally have servers that are just these devices that can only do this one thing. And they only can run code in the secure enclave, so they can only run code that's verified. So even if someone were to get on the server, they couldn't do anything on the server. I don't know if you need that, because you could also just use like an immutable operating system or something. But I guess, yeah, I don't know. Gonna keep reading. Okay, so the enclave is presented the auth key over an encrypted channel, and then the enclave could enforce a maximum failed guess count. For example, if we set the maximum failed guess count to 5, then an attacker who obtained access to the service, or the service operator, would only get 5 password guesses rather than an unlimited number of guesses that they could attempt as fast as their hardware allow. Yeah, so basically what they're saying here is that the security model is that to do additional guesses, you would literally have to go touch the physical servers. Like, you couldn't just get into the server and do additional guesses. There's still a vulnerability, which is like, if the government comes to your data center and says, we're, confiscating these servers, then what are you going to do? And of course, like, basically this model means that you can't, if that ever happens, then all of that data is potentially at risk. Like, because you're using a very simple PIN, instead of using like the 12 words or whatever it was saying, like what you would use for crypto stuff, like blockchain stuff. Yeah, interesting. And since SGX supports remote attestation, clients can transmit these values into the enclave. Yeah, 5 guesses. If you get access to the service, you can't do more than 5 guesses. You would have to actually get access to the hardware. And since SGX supports remote attestation, clients can transmit these values into the enclave over an encrypted channel, with the assurance that they are actually being stored and processed by an enclave rather than someone pretending to be one. Unfortunately, storing a value, yeah, this is what I was saying. Unfortunately, storing a value in an enclave isn't as simple as it might seem. That didn't seem simple to me in the first place. What did they say? It said something earlier. If we put pairs inside an enclave, it's funny to not give any context on that and then hear it later say here how simple it is. Or how it's not as simple as you might have thought. You might imagine a data table that looks like this. You have IDs, guest count, auth token, C2. Okay. The enclave could just maintain an encrypted table on disk, holding the encryption key inside the enclave. Wait, what? What does that mean? At first blush, the enclave could just maintain an encrypted table on disk, holding the encryption key inside the enclave. I don't even know what that means. What does it mean to hold an encryption key in the enclave? What if the server restarts? That won't work, however, because an attacker could just remove the disk, image it, replace the disk. Attacker could just remove the disk, image the disk, replace the disk, run the guest counter down, then repeatedly roll back at the storage volume using the image they took to reset the guest counter. They really don't explain how this works. I have so little sense of how the enclave actually works. How does it store data? Is it not on a disk? Is it in the CPU itself? You can store some values that are persisted for some period of time. What happens if they get deleted? It must be it would have to be some kind of like solid state storage. And what happens if they get corrupted or anything? And you just can't ever access the C2s again? The random bits? I don't know. Not clear. That obviously won't work, however, because an attacker could just remove the disk, maintain an encrypted table on disk, holding the encryption key inside the enclave. And remove the disk, image the disk, replace the disk, run the guest counter down, then repeatedly roll back the storage volume using the image they took to reset the guest counter. Image the disk, replace the disk, run the guest counter down. Emails. Fuck. At first blush, the enclave could just maintain an encrypted table on disk. I assume what they mean here is that the guest counter is also stored on disk. Oh yeah, it has the guest count in the. This is what part of this. The guest count is part of the table. This means all the state has to live in the enclave's hardware encrypted RAM and never touch the disk. Yeah, what I just said. But unfortunately, we live in an imperfect world that is full of surprises like power outages and hardware failures. Yeah, that is the problem. We need to ensure that everyone's data isn't lost in the case the power goes out. Sorry everyone, we lost all your data because the power went out. By somehow replicating the data to other enclaves. Oh, that's interesting. The enclaves can communicate with each other to stay alive, and you better hope they don't all go down. Let's see. We're like halfway through this article. I wonder like who reads this. How many people have read this? e2ee and brute and brute and brute. In the asynchronous replication model that is used primarily by relational databases, that is used by many relational database configurations. In the asynchronous replication model that is used by many relational database configurations, the primary database instance will continue to perform transactions without waiting for any replicas to acknowledge them. The primary instance will continue to perform transactions. Replicas can catch up over time. A slow replica doesn't bog everything down. Because we want to limit the number of times that any potential attacker can attempt to retrieve a value, the retry count is a critical piece of information. Given this reality, there are numerous problems with traditional. So this is an interesting thing for the group service, which is, if you do this, let's just assume continue reading this and assume all of this is fine. This model is designed around if you make too many guesses, you're completely locked out forever. And that's not what most people expect from apps in general. So like you can imagine if I let you create a PIN of 6 digits or 8 digits, and you were trying to log in from a different computer or something, and you guess wrong 5 times or 10 times, whatever the number is, literally you just can never access the data again. That's how Bitwarden works. and some other sort of end-to-end encrypted stuff that limits the number of attempts for you to get in. Basically, you're just out of luck. The nice thing is if you use a long password, like the 12-word model, you don't have to limit the number of attempts because it's just too hard to, like, you can't brute force it. So that's the nice thing with sort of all of the crypto crypto blockchain stuff is like, you can keep guessing. If you lose your key, you can't ever get back in, but you don't have to explicitly lock the user out. Like in Signal's model, if you guess wrong 5 or 10 times or something, they need to lock you out from ever being able to do it again. So at least with longer passwords, you can allow people to keep trying if they can maybe remember it. So anyway. So now it's talking about, given the reality, there are numerous problems with traditional async replication. There isn't anything preventing malicious operator from starting 1,000 replicas, for example. By selectively isolating these replicas and suppressing any transactions from the primary instance that would decrement the retry counter, each of these replicas becomes a new opportunity to keep on guessing. The malicious operator has 10,000 retries instead of 10. Yeah. It's basically saying if they have these secure enclaves on the CPU that hold in memory the C2, that kind of like random key. If you do that on a single server, the server can restart and then you've just lost access to all of the data. So what you can do is you can have the secure enclaves replicate across multiple servers. That way, if one goes down, everything stays alive. Hopefully they don't all go down at the same time, which could happen. It's kind of there was a video I was watching the other day about how when they were testing nuclear weapons in the 60s, they launched a nuke into space and nuked space, and it took out tons of systems for hours and hours. But this was in the 60s and 70s when they were, but it like took out like light poles and things like that because of the EMP effect. So yeah, hopefully that wouldn't happen. And then now you wouldn't have access to anything because, you know, all of your replicated servers had gone down. So what it's saying though is if you do this replication, you have that sort of, I forget what the three consistency, something. You basically can't have perfect consistency without giving up other stuff. And since decrement the retry counter, each of these replicas becomes a new opportunity to keep on guessing. If we switch to a synchronous model where the primary database always waits for replicas to respond, yeah, so if you guarantee consistency, we solve one problem and end up creating many more. This kind of pairwise replication can work for a simple setup where there are only 2 servers, but it quickly falls apart when many more replicas are added. Yeah, because if any replica stops responding, then the entire system fails. So in databases, a lot of times you'll be like, I need 2 replicas to respond, but this doesn't work for this model because you need all replicas to respond because you need to make sure that the attacker can't do more than 5 guesses across all of the systems. And then what happens if a system looks like it's down? You have to wait for that system to come back up to make sure that the attacker hasn't done guesses on that system. We could add logic to the synchronous model to deal with the inevitable outages of an imperfect world, but if a malicious operator is able to tell other members to ignore a replica that has gone missing, they are once again in a position to selectively segment the network and give themselves more guesses. Against a marooned replica, what we're really looking for is a way to achieve consensus about the current state of the retry count. Raft. Yeah, Raft is what... One of the things I deployed recently uses Raft. I think it was Kafka. Strimzy Kafka, I think, is using Raft. According to the Raft website, consensus involves multiple servers agreeing on values. Once they reach a decision... Once they reach a decision on a value, that decision is final. This is exactly what we want. Consensus involves multiple servers agreeing on values. Once they reach a decision on a value, that decision is final. This is exactly what we want. Ben Johnson created an interactive visualization that explains the basic concepts. Let's see. Secret lives of data. So what is distributed consensus? Let's start with an example. Let's say we have a single node system. Yep, okay, we got a dot. I got a big dot. You can think of our node as a database server that stores a single value. We also have a client that can send a value to our server. Ding. Coming to agreement or consensus on that value is easy with one node. But how do we come to consensus if we have multiple nodes? That's the problem of distributed consensus. Raft is a protocol for implementing distributed consensus. Let's look at a high-level overview of how it works. A node can be in one of three states: the follower state, the candidate state, or the leader state. All of our nodes start in the follower state. If the followers don't hear from a leader, then they can become a candidate. Bing. The candidate then requests votes from the other nodes. Nodes will reply with their vote. The candidate becomes the leader if it gets votes from a majority of nodes. Leader election. All changes to the system now go through the leader. Bing. Set 5. Each change is added as an entry to the node's log. The log is currently uncommitted, so it won't update the node's value. To commit the entry, the node first replicates it to the follower nodes, and the leader waits until a majority of the nodes have written the entry. The entry is now committed on the leader node, and the node is state 5. The leader then notifies the followers that the entry is committed. The cluster has now come to consensus about the system state. Log replication, called log rep. About leader election. In Raft, there are two timeout settings which control leader election. First is the election timeout. The election timeout is the amount of time a follower waits until becoming a candidate. The election timeout is randomized to be between 150 and 300 milliseconds. After the election timeout, the follower... Let me check something. After the election timeout, the follower becomes a candidate and starts a new election term. Votes for itself. And sends out request vote messages. Yeah, I mean, this is just standard consensus protocol stuff. If the receiving node hasn't voted yet in this term, then it votes for the candidate. And the node resets its election timeout. Once a candidate has a majority of votes, it becomes the leader. These messages are sent in intervals by a heartbeat timeout. Followers then respond. Yep. This election term will continue until the follower stops receiving heartbeats. Becomes a candidate. Now we've stopped a leader. Node C is now leader of term 2. Requiring a majority of votes guarantees that only one leader can be elected per term. If two nodes become candidates at the same time, then a split vote can occur. Let's take a look at a split vote. Two nodes both start an election for the same term. Bing. And each reaches a single follower node before the other. Now each candidate has 2 votes and can receive no more for this term. The nodes will wait for a new election and try again. Node B received a majority of votes in term 5, so it becomes a leader. Once we have a leader elected, we need to replicate all changes to our system to all nodes. This is done by using the same append entries message that was used for the heartbeats. Let's walk through the process. First, the client sends a change to the leader. It sets 5. Then the change is sent to the followers on the next heartbeat. Set 5. An entry is committed once a majority of the followers acknowledge it, and a response is sent to the client. Now let's send a command to increment the value by 2. Our system is now updated to 7. Raft can stay consistent in the face of network partitions. Let's add a partition to separate A and B from C and D. C, D, and E. Okay, so now it's partitioned. Because of our partition, we now have 2 different leaders in different terms. Let's add another client and try to update both leaders. One client will try to set the value of node B to 3. Node B cannot replicate to a majority, so its log entries stay uncommitted. The other clients will try to set the value of node C to 8. Will succeed because it can replicate to a majority. Now let's try to heal the network. Node B will see the higher election term and step down. Both nodes A and B will roll back their uncommitted entries and match the new leader's log. Our log is now consistent. The end. What's after this? Yeah, I mean, this is pretty simple. It's just general. This is what we want. Okay. Raft is an intuitive system that we knew we could use for secure value recovery, but we had to overcome a few challenges first. To begin with, a few of the existing open source Raft libraries were capable of doing what we needed while operating. To begin with, few of the existing open source Raft libraries were capable. We chose to use Rust for our Raft implementation in order to take advantage of the type safety bubble. We also took steps to make sure that the code is readable and easy to verify. The canonical Raft TLA plus specification code is even includes comments within the source. Our focus was on correctness, not performance. So we did not deviate from the Raft spec, even if there were opportunities to speed up certain operations. With Raft, we gain the benefits of a strongly consistent and replicated log that is a nice foundation for our purposes. Oh. What? Trying to zoom in. However, the Signal user base is constantly growing, so a static collection of machines in a single consensus group won't be enough to handle a user base that keeps getting bigger. We need a way to add new replicas. We also need a way to replace machines when they fail. It's tempting to think of these as two separate concerns, and most people treat them as such. The routine process of node replacement becomes second nature, while the less frequent act of setting up a new consensus group remains a white-knuckle affair. We realized that we could solve both problems simultaneously if we had a mechanism to seamlessly transfer encrypted ranges of data from one consensus group to another. Yeah, I mean, like, just thinking about this, it's so obvious how this is like a super high thought out system, and like, but there's just potential vulnerabilities all over it, because it's just, there's a lot of things that need to happen right here and other things that need to not go wrong for all of this to not have any vulnerabilities. And if you're using Signal specifically because you don't want vulnerabilities, then we realized that we could solve both problems simultaneously if we had a mechanism to seamlessly transfer encrypted ranges of data from one consensus group to another. This would allow us to replace a failed node in a replica group by simply creating a new replica group with a brand new set of healthy nodes. It would allow us to rebalance users between an existing replica group and a new one. In order to make these data transfers possible without interrupting any connected clients, the traffic director. In order to make these data transfers possible without interrupting any connected clients, we developed a traffic director that consists of a front-end enclave that simply forwards requests. Traffic director that consists of a front-end enclave simply forwards requests to backend Raft groups and re-forwards them when the group topology changes. They basically have a proxy for their enclave servers. We also wanted to offload the client handshake and request validation process to stateless front-end enclaves that are designed to be disposable. We also wanted to offload the client handshake and request validation process to stateless front-end enclaves that are designed to be disposable. Yeah, so these enclaves have to run the specific code that they designed, but they don't have any sort of state that they need to make sure exists. This reduces load and simplifies logic for the backend replicas that are storing important information in volatile encrypted enclave RAM. This is such a crazy setup. If they lost all their servers at the same time, for any reason, I mean, you're just done. All the data's gone. The distributed enclaves all verify each other using the same Mr. Enclave attestation checks. The signal clients perform. Distributed enclaves all verify each other using the same checks that the signal clients perform to ensure that their code has not been modified. A monotonically increasing timestamp is also synchronized between enclaves to ensure that only fresh attestation checks are used. And communication between enclaves leverages constant time curve to 25.519 and AES GCM implementations for end-to-end encryption. Communication between enclaves uses end-to-end encryption. That's all it's saying here. I don't know what the noise protocol is. Let's just HTTP. That's pretty funny. Noise. It does. By treating node replacement as an opportunity to simply set up a new replica group, we reduce node replacement as an opportunity to simply set up a new replica group. We reduce complexity and leverage a predictable process that can easily expand with Signal's growing user base. Yeah, so every time they set up a new node, they copy that node's state or something. Let's take a look. Cloud provider 1 and cloud provider 2. The signal client. Request is sent to the load balancer. The load balancer sends the request to the front end. The front end request is forwarded to the Raft group replica. And the request is replicated to the other replica group. Other replicas next. This doesn't tell me very much. It's not obvious how this ties into the secure value recovery setup. The service is composed of many SGX clusters, shards, spanning multiple data centers. Clients connect to a front-end node, establish an encrypted channel, and perform SGX remote attestation. Clients submit its request over the encrypted channel, either storing their C2 value or attempting to retrieve their C2 value. The client's request is replicated across the shard via Raft. All replicas in the shard process the request and respond. SGX enforces strict checks during the attestation process. These requirements include always using the latest CPU microcode. SGS enforces strict checks. Always using the latest CPU microcode, which must be loaded before the OS and therefore updated at the BIOS level, as well as disabling hyperthreading and integrated graphics processing. If a service operator falls behind on these patches, the attestation checks that the client performs will begin to fail. These enforced upgrades, it's kind of crazy. I guess AWS and Google Cloud just provide this hardware, supposedly. And you have to hope it's not fucked up. I mean, I wouldn't trust that. Fucking make their own CPUs for AWS that are fucked up, so yeah, I would not trust that. These enforced upgrades provide a level of protection as new attacks and mitigations are discovered, but we want to take things further. Many of the recent exploits that have led to CPU information leak vulnerabilities are the result of speculative execution. Oh, that's all I wanted. Taking advantage of the CPU's speculative execution. The CPU tries to guess what path you're going to take next. I guess you can exploit that in some stuff recently. Compilers such as LLVM have started to implement techniques like speculative load hardening. One of the approaches, it's pretty funny because like speculative execution makes your CPU run faster, and then that like puts you at risk of vulnerabilities because it loads stuff into CPU caches that shouldn't be loaded in. One of these approaches to this problem is to add LFENCE instructions to an application, according to the LLVM documentation. This ensures that no predicate or bounds checks can be bypassed speculatively. However, the performance overhead of this approach, simply put, is catastrophic. Yet it remains the only truly secure by default approach known prior to this effort and serves as a baseline for performance. Yeah, that sucks. You have to disable speculative execution entirely. A secure value recovery service will still be perfectly functional even if it takes slightly longer to process results. Once again, the focus was on correctness instead of speed, so we forked Bolt, a post-linked optimizer developed to speed up large applications. Facebook Incubator / Bolt. Binary optimization and layout tool, a Linux command line utility for optimizing performance of binaries. This directory and its subdirectories contain source code for LLVM. So we forked Bolt, a post-link optimizer developed to speed up large applications. Then an ironic twist, we added an automated LFENCE inserter that significantly slows down. I see. So they're saying they forked Bolt before they added this LFENCE thing. And the LFENCE kind of defeats the point of using Bolt. Significantly slows down application performance but makes the operations more resilient. Additionally, Bolt automatically inserts repo lines, help mitigate speculative execution exploits. LFENCE insertion is enforced as part of the build process, and an automated check verifies the presence during compilation. Because no clever optimizations are taking place and an LFENCE is proactively inserted before every conditional branch without any consideration for performance impact. The correctness of these instructions is easier to manually verify as well. Future possibilities. All this adds up to a secure enclave that limits the number of recovery attempts that are possible against a value. Synchronized across nodes. All this adds up to a secure enclave that limits the number of recovery attempts that are possible against a value, synchronized across nodes in a hardware encrypted RAM. Yeah. I don't think I can implement this. I gotta think about this. It seems ridiculous. In the longer term, we'd like to mix in component recovery splitting across other hardware enclave and security module technologies, as well as component recovery splitting across organizations as it's developed and deployed in other places. In the long term, we'd like to mix in component recovery splitting across other hardware enclave and security module technologies. I don't know what that means. Let's skip these. As well as other component recovery splitting across organizations as it's deployed in other places. We'd eventually like to get to a place where the protections afforded to us by secure value recovery incorporate a lattice of mixed hardware and hosting. This is a really crazy setup. I wonder if anyone outside of Signal has a setup like this. This is so much work. I wonder if Apple has anything like this for their iCloud encryption. I highly doubt it, but it's possible. This is something like Apple could do so much more trivial than Signal can do, because Signal is just using AWS and stuff. and Signal has no power to get their own CPUs built with their own hardware for those CPUs. So yeah, this is kind of a crazy thing to set up. While it's not difficult to split C2 using conventional techniques like Shamir secret sharing, Shamir secret sharing is an efficient secret sharing algorithm for distributing private information among a group. So you could split C2 across multiple devices if you wanted to, maintaining a single auth key, which would be vulnerable to offline guessing attacks. Across all of these nodes would undermine any value from secret sharing. So yeah, you could split C2, but you fundamentally have to have a single auth key at the end of the day. So instead, we could have clients reconstruct an auth key by asking each server in a quorum to evaluate a function of the user's password and each server's secret key, without the server learning the input password or the output. So instead, we could have clients reconstruct an auth key by asking each server in a quorum to evaluate a function of the user's password and each server's secret key, without the server learning the input password or output. Okay, and then rehashing these outputs together. Yeah, I mean, they don't explain this at all. The source code and documentation for the secret value recovery service are now available. We appreciate any feedback. Moving forward, we are evaluating opportunities to incorporate this recovery method into the application, and we'll share additional details about what we discover in the process. All right, this is not possible to implement. The entire purpose of this was because they want a somewhat memorable thing that you can use as your password, a PIN code, and they need to add some randomness to it and then store that. If they just required users to have like 12-word passwords, they wouldn't need any of this, or most of it. They wouldn't need the crazy storing stuff in RAM permanently. But it's a big question for this setup, which is like, you know, do you require users to have pretty strong passwords? If they forget those passwords, they're just locked out of their account permanently. And if you don't do what Signal is doing here, then the passwords have to be pretty long. The reason this is so hard is because no other companies care about privacy for the most part. Otherwise, this hardware would mostly exist. Like, it's just, I mean, some companies care about it a little bit. AWS and Apple probably both have their own sort of internal things for dealing with stuff like this a little bit. But yeah, nothing Nothing is just available off the shelf. If more companies did this, then there would just be, you could buy the old servers and stuff and set this up yourself in a reasonable way. But this is pretty unreasonable setup. Okay. I don't know what I'm gonna do. It's a pretty core thing how to manage passwords or access to your master vault for happy groups if I do everything end-to-end encrypted. I think I would have to just let you use your email to reset the password. Because in my head, if you do it any other way, most users are not going to use a password manager, and whatever password manager they are going to use is going to be pretty bad. That's probably another reason Signal did the passcode thing, the digits. I think you make it a lot of digits since people are just gonna like use their phone number. Location-based search. Default to automatically only show new members content. What happens when a user leaves a group? If they come back and they see the post from when they were a member before? I don't know. I wonder about the idea of a temporary group. Temporary groups. Should polls be their own section or page in groups? It'd be nice to be able to filter it. Yeah. Add this ability to filter by poll on the home feed. We should show events you're attending. Yeah, I don't know about that. That's group size. This. The end-to-end encryption is such a pain. Oh, it feels like a wall. I think I have to give up some level of encryption or some level of security. I can't do what Signal does. It's just like when you start doing that, when you start giving up certain levels of security, it makes you wonder what's the point of having any of it. Like there's still security, but that's how it feels. I don't think it's an incorrect feeling, but like I still think it's worth having everything encrypted, even if it's like, if a user uses a bad password or something, it's easy to crack that and get access to the groups that they're in. It's still nice to not have all of the data just publicly, not publicly, but within the whatever app you're using or something. Yeah, I'm gonna have to make trade-offs. I think that's probably where the biggest trade-off's gonna have to be, is in how users can access their account. I'm gonna have to get backup mechanisms, and those backup mechanisms are gonna expose risk. But I can do a lot with just that one concession. Everything else, like I can't sacrifice the entire experience of the app on, you know, you got to remember a 12-word password or something, even though it's like it only happens when you log in. It's just not viable. And I'm not going to do what Signal did. I think the open question would be, you know, do you make recovery impossible if you don't know the password? I think I would rather require a strict password and give recovery options. And ideally support things like passkeys, so someone can just use their Face ID or fingerprint to access it. Yeah, and I think what I'll do is in the settings, I'll have the option that you can either disable or enable the you can disable or enable the email recovery option. So if you wanted your account to be more secure, you could disable the recovery option. And then you just take the risk that if you lose the password, then you're screwed. But okay. Well, I made some projects. I gotta add some more tasks to these. I gotta go to the store and I gotta pick up some stuff. Some hard drives. I gotta try to hopefully recover my dead hard drives tonight that I dropped. So where do I want to go? What I'm trying to do right now is just, I got to make trade-offs, and I'm just trying to, where am I making the trade-offs? Because you don't want to do like some stupid thing where you're doing some really secure thing, and then you realize like, I just can't make it secure. Like it's just no, like you're overdoing it in some area and you're underdoing it somewhere else. It just not worth doing. So I think I have a pretty good sense overall of how this is all going to work. The encryption. It's pretty hard, but I don't know, it's fun, interesting. I really wish, I don't know it's that valuable of a skill even to develop, because like if you get really good at this, where do you go work? Like cares, and no one cares about your privacy for the most part. I mean, Apple a little bit, but yeah, I think like you could go to Signal, but Signal's a non-profit. Yeah, I think I'm basically going to end up in the world of WhatsApp, a little bit better than WhatsApp, but I'll have to kind of model a little bit more after WhatsApp. Let me actually look that up. Does WhatsApp, how do passwords work with WhatsApp? What if you forget your password? WhatsApp doesn't use traditional username and password. Instead, you use your phone number. When you set up WhatsApp, you verify ownership of the SMS. WhatsApp offers an optional 6. I guess that makes sense because you don't have... just because you have the phone number doesn't mean you have access to their history. So even though they could like message all your friends and pretend to be you with your phone number, I mean that's kind of true with your phone number anyway. So WhatsApp offers an optional 6-digit PIN you can enable in settings. This PIN is required whenever you or anyone tries to register your phone number with WhatsApp again. What happens if you forget? You never register your phone number again? Oh, it says here. I'm writing a question, it's literally answered already. If you add a recovery email, WhatsApp will email you a reset link. If you didn't add an email, you'll have to wait 7 days before you can re-verify your number without the PIN. During this waiting period, whoever has access to your phone number can't get into the account either. If you didn't add an email, you'll have to wait 7 days before you can re-verify your number without the PIN. During this waiting period, whoever has access to your phone number can't get into your account either. You can also request a reset link from the login screen, which will disable two-step verification after 7 days if you don't act on it. The reason this is different than this group setup is because with WhatsApp, you don't get access to the history. Even if you get access to the phone number or the user's email or something like that, like you can't see all their messages. But in my groups app, I have the history. So I can't rely on anything like that. But I mean, it's just at the end of the day, that's how it's going to have to be. Like if your email gets hacked or whatever and they send a reset link to the email, it's like they're going to get access to your history. And I guess I could do something where you can disable history polling on new devices without some kind of... I could have a 2-password setup. Basically, you could have a password where you can log in as a user, but you don't pull any of the history down. And then if you wanted to, you could enable a... It's like, by default, whatever your password is gives you your history. But if you want to, you could have a second password, which is required if you want to get access to the history. So your history could basically be kept entirely separate from your kind of like login password. And you risk losing all your history if you don't remember that kind of longer recovery password. But that would be a good way to do it. So you kind of separate out fetching the history. You essentially have no backup for fetching the history. You can log into your account again. The thing would be that you want to be able to be in the group still. So I better write this down so I don't forget. Let's say we split the ability to log in to your account and be in your groups to a password code login plus optional email reset. We could then let's say The ability to log into your account and be in your groups is done through a password, an optional email reset, and then separately, the ability to fetch your group histories, with the groups is a passphrase and no email verification. So it would be somewhat possible to take over someone's account, but not really their history. Yeah, I like that. The risk, this would be an optional feature users could enable. Splitting history auth from login auth. Feature users could enable. The default would be that your password email tie your groups. Your account. Yeah. The thing is, if you make that the default, I kind of would prefer the default is that your history is not tied to your login email. But I don't know if that's viable. I'm gonna change this font. All right. I think I will stop here for today. I'm gonna have to think about this for a day or so. My limit resets for Claude tomorrow afternoon, so that's probably kind of what I'll time box myself on. Where did my Claude session go? I used to have a window open. Fluid. Settings. Yes, I'm at 95% of my usage. The limit resets at 1 tomorrow. And then I think I'll try to have basically a list of all the trade-offs I want to make and kind of decision points. And there's still just some basic stuff I'm going to have to do for like setting up a server that are completely independent from how the actual encryption works. So I'll start doing those things. The only thing with doing the backend stuff is that it's going to be pretty slow going because none of it's really going to show up on the front end until I have things working, and that's going to require the full end-to-end encryption setup, like user accounts and all that stuff. So basically progress on like a visual front is going to completely stop now, which I'm fine with, but it's less entertaining to watch. So yeah, and I mean, I could spend another day or two on the front end. I just don't think, I mean, I've gotten 90% of the stuff done I want to get done right now. And then once I start getting the back end and encryption set up and start trying to hook all the stuff up, that's when I'll realize like, oh, this doesn't work. You know, like I can't do this thing I think I that I thought I was going to be able to do. So that's fine. I think ultimately, if I could finish this in 6 months, I could get this fully end-to-end encrypted working. You can create groups, log in, share photos and videos and stuff. Yeah, I'd be very happy with that. So keep up the momentum. Keep trying. One foot in front of the other. To do some more work to, I'll probably do that a little bit tonight, do some more work to clean up tasks I have inside my, kind of stream notes, my daily stream note, put those into the GitHub project, GitHub projects, and then maybe figure out how I'm going to organize Google Drive docs. Maybe I'll just make those all public too, because they're kind of interesting. It'd be nice to open source the code. I'm not totally opposed to doing it, but I do worry if I implement something wrong, there's like, I mean, there's no check on me. Like, if you just have access to the, you just very easily see where there's issues or stuff. And if I like decide to retroactively do it, Signal, the front end is open source, but not the back end. And I think that's kind of generally the model you want to go with. I mean, in theory, like the way things are implemented, it shouldn't matter to open source the back end. It would be nice if the back end was implemented. The front end is the thing that actually like does the encryption and stuff. So hopefully I keep improving on explaining stuff. That's what I've been trying to practice a little bit with the streaming. Like even if not that many people watch, it's I think it's a good skill to practice. Either way. And then I also have the other thing that's been kind of nice with having all the streams is that it's kind of like I'm documenting for myself all the stuff. And even, for example, for the front end, like I was looking at yesterday, you know, how long does this take? It's always usually really hard to estimate this stuff, especially with the LLMs. You don't know how long something's going to take. And I mean, I wouldn't be able to guess how long this would take today with sort of Claude code and things like that. So this ended up taking about 50 hours of work. Yeah, and so it's just very useful to have that. And then I find it lets me time box stuff a little bit better too, because when I go back and I look at my stream topics or thumbnails, I can like see how much time I spent on different things and like, you know, do I want to spend more time in that area? How much time am I willing to spend on encryption versus setting up a backend service and stuff like that? So I think the streaming has value even if no one watched, but anyways. Yeah, I'll try to keep improving on streaming and explaining stuff and whatever. I need to find more royalty-free music because this is not going to work long term. There's like 300 songs YouTube gives you access to for royalty-free music, and I just have to keep playing them over and over again because after about 6 hours I've gone through all of them. But yeah, there's not a lot of great royalty-free music. And if I use any music that's not royalty-free, then I immediately get copyright strikes. Yeah, I think It'd be nice to get the projects implemented, I think, for suggestions and stuff. People can create issues. I need to look into that a little bit more. I'm messaging my friend about how he does that with his open source projects. Because I want to keep track of all of this, like, kind of publicly, the tasks that I have for each type of thing, and then the docs would be nice too to keep public. Like even Signal's blog posts themselves are very useful for me here, right? Because I can like look at them and be like, oh yeah, this is not going to happen, or it is possible, you know. And they didn't really have to put those out. Okay, I'm gonna call it here for today. Yeah, I'll be on tomorrow. Thanks for watching. Catch you later.